Hello everyone and nice to meet you. My name is Aiden Teaches Math and it's a good day. And today I'm going to tell you that nobody in America knows except professors, and nobody in America has ever told you except you're a college student in Cambridge or Princeton. So let me tell you about this. So now what I'm going to tell you about is the characteristics of symmetry and ratio relationships of a cubic function. And it looks like this, and it's x cubed, something like this. So now let's get back to the next slide and talk about the quadratic function's characters. So if you have a quadratic function like x squared, and we just draw a line, I don't know what this line is, but it meets at the x of alpha and beta, then when you draw a parallel line to this, let me draw it as blue. If you draw a parallel line to this, at here, that only meets at one point, then this place is of course alpha plus beta over 2. Okay, this is the only characteristic you should know about the quadratic function when I'm talking about you. So this is a caution. Please memorize it. If you do not memorize, I won't like you. Okay, now the cubic function. So what I want to tell you is that 1472 is my current view count, but I want to make this to 1500. So please help me. Now let's get back to the next slide. So now we're going to talk about the real cubed functions you are probably thinking of, like x cubed and something like that. So if you have a cubic function, this is cubic, and if you have the local maximum of alpha and the local maximum of beta, you know what maximum and minimum is, right? So if there's local, then it's just this partially. Then this is the maximum and this is minimum. So alpha is the local maximum, the beta is the local minimum. But back to my point, when there's alpha and there is beta, and when I draw a line that only meets at this one point with the function except here, and the same line on beta, and draw a straight line towards each other, and in the middle, there's a inflection point, and when you go through it, like this, does it look the same? So, what I'm trying to tell you is that when there is a cubic function and you draw it like this, and there is these lines, then this, and this are going to be the same. Like in here, this looks most the same. Yeah, this is my first point. It is 1, 1, 1, 1, exactly proved by professors. Now, next to my point. Character number 2. So, if you draw a cubic function that has 3 x's, that fx equals 0, then let's call it alpha, beta, and gamma. Then alpha plus beta plus gamma is 3 times inflection point. Actually, it's not just the inflection point, it's the inflection point's x. But anyways, let's take a proof at it. Here's beta and here's gamma. Then alpha plus beta plus gamma is minus a under b if we take the function fx as ax cubed plus bx squared plus cx plus d. But when we calculate the inflection point, did I tell you? I told you about this, and this is 1, 1. Or I can prove it in a different way, but let's look at it. So if we make this f prime x, this is 3ax squared plus 2bx plus c. But when f prime x is 0, it is these and these points. Let me swap the colors. These and these points are f prime x is 0. So 3ax squared plus 2bx plus c equals 0. Then this plus this is, let's call it alpha, beta, gamma, delta, and epsilon. Then delta plus epsilon is minus 3a under 2b. But here is 1, 1. So delta plus epsilon is zeta. So zeta is minus 3a under b. Then we can prove that inflection point is zeta. So let's just write zeta. So 3 times zeta is minus 3a under b times 3. So this is minus a under b. And alpha plus beta plus gamma is of course minus a under b. So this is exactly the same. Proved. Now, next slide. Just a practice. It's just a practice. Don't get afraid. When we have a function like this, alpha, beta, and gamma, and let's just give me f prime x for your ease. F prime x equals x squared plus 6x plus 8. Then, fx is probably something like, let's just times 3. Then fx is probably something like x cubed plus 9x squared plus 24x plus 19 or something like this. Then what is alpha plus beta plus gamma? Or just find here and here, since this is minus 2 and this is minus 4, then the inflection point is, of course, 3 plus minus 4, so this is 1. So 1 is the inflection point. Sorry, I did it wrong. Minus 4 to minus 2 is minus plus 2, so when you plus 1 and minus 4, then this becomes minus 3. So the inflection point is minus 3. And alpha plus beta plus gamma is 3 times zeta, which is 3 times minus 3, so minus 9 will be the answer to my question. Thank you for listening, and this was Aiden Teaches Math, teaching you useful tips for derivating cubic forms of a function and the ratio and the symmetry of a cubic function. Thank you for listening, and this was Aiden Teaches Math. Watch my other videos, and thank you.